Welcoming you all. In today's session, we will see one real-time case study related to the queue data structures. First, we will see the problem statement here. Consider there is a scenario like that. Peter and Maria went to the movie one day. In that multiplex, the tickets were issued in the first come first serve basis, and people were standing one after another for getting the ticket for the turn. So they Peter and Maria went to the back and should and began and should begin the last person waiting for the queue. So from that scenario, we there are three possible questions were raised. One is should people stand in a particular order for buying the ticket? The second one, when Peter and Maria arrived, where did they stand for buying the ticket? And third one, in what order the tickets will be issued to buying the to the people standing there. So these are all the questions were raised. So anyone can guess what is the solution can be given to the above scenario? Yes, the solution to the above scenario is queue management. Already you know about what is a queue. In the last class itself, we will see about what is the queue data structures, what is the basic operations of queue. So this is problem. This problem statements can be solved using the queue management. So before going into the solution, first we will see what is a queue. Queue is nothing but it is a linear data structures. It is follow the mechanisms of first in first out. The first in person is going out first. So this is the mechanism is followed by the queue data structures. The operations possible on the queues are, one is an NQ and other one is the DQ. NQ is called it as an addition. So we can add an element at the end of the queue. The end of the queue is called as a rear end. The DQ means we can remove an element from the front of the queue. The DQ is placed in the position is called as a front. So the NQ is done at the rear end and the DQ is done at the front end. These are all the two positions we followed in the queue data structures. First we will see what is an NQ. So the NQ means suppose one person is entered means where the person should stand. So the newly entered person should stand at the rear positions. So the algorithm for that NQ is that first we will check whether the queue is full or not, because whether the queue is full means we cannot insert any element in the queue. So we check the queue is full. If it is not means increment the rear end, that is equal to rear plus 1, and add the element at the position in the rear positions. So this is an algorithm we will follow for NQ or add a new person at the queue. So next one is a DQ. So what is a DQ means? Suppose the person is getting the ticket and removed from the queue means that is called as a DQ. So the DQ is a deletion operation that can be done at the front end. The algorithm for DQ is first for the DQ, first we have to check whether the queue is empty, because in the empty queue we cannot delete any element. So that is the first checking condition we should follow in the DQ operation. If the queue is not empty means we can retrieve the data at the front of the queue. So for that we can increment the front by 1 and return the retrieved data. This is an algorithm for DQ. So what is the, I can repeat once again. So first we will check whether the queue is empty or not. நம்ம ஃபஸ்ட்டு வந்து queue எம்டியாக இருக்கான்னு பார்க்கணும். If it is not means we can retrieve the data at the front end. For that retrievement, what is the statement we will follow in the algorithm means increment the front pointer 1, that is front is equal to front plus 1. For the NQ operation we can increment the rear end at 1 position. In the DQ operation we can increment the front pointer plus 1 position. So after incrementing the front means the first person is removed, the front is come to the previous next positions. Now we will return the retrieved data. This is the DQ operation performed. So this is the queue management will follow in the ticket booking systems. I hope you will understand what is the NQ-DQ operation and how the queue management is done in this real-time scenario. So not only this scenario, wherever we follow the queue, that is the ticket booking systems, and then for example in the printing system also we have the queue. So for all the management applications, we can follow the same two operation, one is the NQ and DQ. I hope you will understand the queue data structures and operations of NQ and DQ based upon this scenario. So the solution to this problem statement is a queue management system. Thank you.